So we know how to take partial derivatives of multivariable functions. There's such a thing called partial differential equations, and those are equations that have the partial derivatives in them, like this example here from the heat equation. And what you're supposed to do to try and solve partial differential equations is you're trying to figure out the original function. So the original function that satisfies the partial differential equation. It's very hard. We're not doing that in this class. We won't be solving partial differential equations. At most, I'll ask you to do something like in this example that we're going to do, where we give you the answer and you just check to see if it's the answer. So let's do that example. Here's a heat equation. So we've got z as a function. It must be that z is a function of x, because here's its second derivative with respect to x, its second order homogeneous partial with respect to x, and here's its first order derivative with respect to y. So it must be a function of at least x and y. So here's what we're saying is the solution as a function of x and y. So here's our heat equation. We want to show that this function solves this equation. So is a solution. So let's get the partials that we want. The first partial derivative that we want is the derivative with respect to y. So I'm differentiating this function, our answer, with respect to y. So the derivative of 3 is 0. The derivative of sine becomes cosine. Leave the middle alone. And then multiply by the derivative of what's inside. The derivative of what's inside with respect to y is minus k. I'm going to put that on the outside here. So there's the left-hand side. Let's get the right-hand side. So I need z sub xx. So I need the derivative first with respect to x. So I'm differentiating this function with respect to x. The derivative of 3 is 0. The derivative of sine is cosine. Leave the middle alone. Multiply by the derivative of what's inside. Remember, I'm differentiating with respect to x, so the derivative of what's inside is a 1, so I'm not going to write it. Now I need the z sub xx, so I'm going to take what I've already differentiated once with respect to x and do it again. The derivative of cosine is minus sine. Leave the middle alone. Multiplied by the derivative of what's inside, again a 1. So now I'm trying to show that this is a solution. So the left side of this equation, so ls for left side, the left side is z sub y, and that's, and the right side is equal to k times our z sub xx. I'll move the minus over here. And yeah, left side equals right side. So it is a solution. That's all we were doing. Now in a real partial differential equations class, we would just give you this, and you would have to figure out the function. It is a lot harder. It's so hard, in fact, that many of these equations, these partial differential equations that actually have solutions, are, have names. Heat equation, Laplace equation. They got names after people that worked on them in the olden days. Anyway, we just want to understand what we can do with the derivatives and check that they solve a partial differential equation.